Have you ever gazed at the night sky and pondered how this vast cosmic neighborhood, our solar system, came into being? Welcome to an exploration of our celestial home's origins. We'll delve into the fascinating process that led to the formation of the sun, the planets, and other celestial bodies. Understanding our cosmic genesis not only satisfies our curiosity, but also offers insights into the workings of the universe. Stay tuned as we journey back in time to unravel the birth of our solar system. Our story begins nearly 14 billion years ago with the Big Bang. This cataclysmic event wasn't an explosion in space, as the name might suggest, but rather an explosion of space. The universe began as a hot, dense point nearly infinitely small. Then, in a fraction of a millisecond, it expanded in all directions at once. The energy of this expansion eventually cooled and condensed into the matter we know today, creating atoms, stars, and galaxies. The swirling clouds of gas and dust, known as nebulae, formed the building blocks of galaxies. Within these galaxies, under the influence of gravity, nebulae collapsed to form stars and their surrounding planets. This is how galaxies, stars, and ultimately our solar system came into existence. The birth of our universe and the formation of galaxies were not just cosmic events. They were the start of a stage that would eventually lead to the creation of our own solar system. With the stage set, our solar system was ready to take form. Around 4.6 billion years ago, a cloud of dust and gas, known as a nebula, started to collapse under its own gravity. Fascinating, isn't it? This nebula, a vast space cloud, was indeed the birthplace of our solar system. This idea is central to the nebular hypothesis, a widely accepted explanation for the formation of planetary systems. The nebular hypothesis proposes that our solar system originated from an enormous rotating cloud of interstellar gas and dust. This cloud, or nebula, was likely disturbed by a force, perhaps the shock wave of a nearby supernova. This disturbance caused the nebula to collapse under its own gravity, leading to the creation of a spinning disk of material. Imagine a pizza dough spinning in the air, getting flatter as it spins. Similarly, as the nebula collapsed, it began to spin more rapidly, creating a flattened, spinning disk of gas and dust with a bulge at the center. This central bulge is of utmost importance. As the nebula continued to collapse, the material in the center of the disk became increasingly dense and hot. Eventually, it reached such high temperatures and densities that nuclear fusion was triggered, giving birth to a new star. This star, my friends, is our sun. In the throes of its birth, the sun released a powerful stellar wind. This wind swept away most of the gas and dust from the inner part of the nebula, leaving behind only the material too heavy or too far away to be affected. The remaining gas and dust would go on to form the planets, moons, asteroids, and comets of our solar system. But that's a story for another scene. Our sun's formation is a testament to the immense forces at work in our universe, forces capable of shaping galaxies and birthing stars. It's a reminder of our humble beginnings in a cosmic cloud of gas and dust. And thus, our sun, the heart of our solar system, was born. It's a fascinating story, one that reminds us of the intricate and incredible processes that have shaped our corner of the universe. In the swirling disk around the young sun, something remarkable started to happen. As the solar nebula continued to spin, dust and gas began to collide, and an incredible process, known as accretion, commenced. Accretion is a bit like the ultimate cosmic recycling program. It's where dust and gas particles start sticking together, forming larger and larger clumps. Picture a snowball rolling down a hill, gathering more snow as it goes, growing bigger and bigger. That's accretion in a nutshell. Or perhaps more appropriately, in a planetesimal. Now, what's a planetesimal, you may ask? Well, these are the building blocks of planets. They are the initial lumps of matter, often just a few kilometers across, that form through accretion. Imagine them as cosmic Lego blocks, the first pieces in the grand construction project of planet formation. As these planetesimals continue to collide and stick together, they form bigger structures, called protoplanets. These are essentially baby planets, not yet fully formed, but well on their way. They're like teenagers in the planetary life cycle, still growing and changing. Now here's the cool part. As these protoplanets grow, their gravity also increases. This increased gravity pulls in more and more material, causing the protoplanet to grow even larger. It's a snowball effect, quite literally. Over millions of years, these protoplanets continue to grow and evolve, eventually becoming the planets and other bodies we see in our solar system today. Every planet, every moon, every asteroid started out as a tiny speck of dust in the solar nebula. Now, isn't that a humbling thought? It reminds us of how interconnected everything in the universe truly is. And there you have it, the process of planetary accretion, the next step in the journey from a cloud of dust and gas to a fully formed solar system. It's a testament to the incredible power of nature and the laws of physics. From dust to planets, the transformation was truly cosmic. Our infant solar system was a violent place. Imagine a toddler's playroom, where toys are flung around with wild abandon. That's a bit like what our young solar system was like during a period known as the Late Heavy Bombardment. This was a time, roughly 4 billion years ago, when our cosmic neighborhood was still shaping up. Picture countless asteroids and comets, these cosmic wanderers hurtling through space with reckless abandon. These space rocks, some as small as a pebble and others as large as a city, were like cosmic billiard balls, smashing into the young planets with immense force. But why was there so much chaos? Well, it's believed that the giant planets, Jupiter and Saturn, were moving around, and their immense gravity was stirring up the asteroid belt and the Kuiper belt, the two main reservoirs of these space rocks. This sent a rain of asteroids and comets towards the inner solar system, causing this period of intense bombardment. But this wasn't just a cosmic demolition derby. These impacts played a crucial role in shaping the planets. The craters we see on the Moon, Mars, and even here on Earth are scars from this tumultuous time. They're a stark reminder of the solar system's violent past, and it wasn't just about reshaping the landscape. These asteroids and comets were like delivery trucks, possibly bringing with them water and other essential elements. You see, these celestial bodies are remnants from the early solar system, and they're packed with water, organic compounds, and other crucial ingredients for life. So, when they slammed into Earth, they could have delivered the necessary components for life to begin. So, this period of chaos wasn't just about destruction. It was also about construction, about creating the conditions for life as we know it. It was a time of creation through chaos, a process that continues even today, albeit at a much slower pace. After all, this period of chaos was crucial in shaping the world as we know it. Fast forward to today, and we find a solar system full of wonders. Our solar system as we know it now is a bustling neighborhood of celestial bodies, each with its own unique story to tell. At the center of it all is the sun, a glowing sphere of hot plasma, providing the essential energy that fuels life on Earth. It's a medium-sized star, but in our solar system, it's the king, holding the planets and other bodies in its gravitational embrace. Circling around the sun, we have 8 planets. The inner planets, Mercury, Venus, Earth, and Mars, are rocky bodies. Each one is unique, from Mercury's cratered surface to Earth's blue oceans and bustling life, to Mars' red dust storms. Beyond Mars lies the asteroid belt, a sort of cosmic rubble left over from the solar system's formation. Further out, we find the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. These planets, with their rings and numerous moons, add a sense of grandeur to our solar system. Beyond Neptune, we find the Kuiper belt, home to many icy bodies, and Pluto, a dwarf planet that still sparks debates about what it means to be a planet. But the solar system isn't just about planets and the sun, it's also teeming with asteroids, comets, and meteoroids. These smaller bodies, while often overlooked, provide valuable insights into the solar system's past. Studying them helps us piece together the history and evolution of our cosmic neighborhood. And let's not forget the Oort cloud, a theoretical sphere of icy bodies believed to be the source of long-period comets. It's at the outermost edge of the solar system, a frontier that we're yet to explore. Each of these bodies, from the sun to the smallest comet, holds a piece of the puzzle that is our solar system. As we study them, we continue to uncover new insights into how our corner of the universe came to be. Our solar system, a testament to the cosmic ballet of creation, continues to captivate us. So, we've taken a journey from the Big Bang to the present day, witnessing the birth and evolution of our solar system. From the cataclysmic explosion that marked the beginning of everything, to the nebular hypothesis explaining the formation of celestial bodies. We've explored the process of accretion that led to the formation of planets and the late heavy bombardment that shaped them. Today, we marvel at our current solar system, a testament to these cosmic events. The next time you gaze upon the night sky, remember you're looking at a cosmic tale billions of years in the making.